So, topic is induction machine. So basically, induction machine, we have a stator and as well as rotor. The stationary part is stator, the rotating part is rotor. So I'm drawing the circuit, simplest circuit. Let it is a stator, this is rotor. In any machine, we have a stator as well as rotor, no doubt in that. The basically nowadays we are using 80 to 90% induction machine. It is very popular motor. Okay. So in stator part, we have a three-phase winding. Three-phase winding. And in this three-phase winding, we are supplying three-phase balance power supply. When you supply three-phase balance power supply to this three-phase winding, there is a rotating magnetic field. Basically, you will see here, it is magnetic field which is rotating at what speed? It's ns speed. Ns means synchronous speed. That is 120 f upon p. What is f? That is frequency. This is p is equal to pole. So this is the main basically the principle of induction machine. When you supply three-phase power supply to three-phase winding, there is a rotating magnetic field which rotate at ns speed. Secondly, what about rotor? See, there are two type of rotors basically in induction machine. First one is squirrel cage motor rotor, and second is slip ring induction motor. So here you can see the PPT. I am showing you PPT. This is a sample lecture on induction motor. Induction machine. This is a construction basically. So in stator we have three-phase winding, okay. And in rotor, basically there are two type of rotor. First one is squirrel cage induction rotor. Second is slip ring induction rotor or phase bound induction motor. Both winding carry AC. Okay, we will see later that what is the mathematical equation formed. Okay, now induction machine can operate at both motor as well as generator. As generator's performance is not satisfactory. Why I am saying this? Because in induction generator, basically the problem is it is taking reactive power from the supply, reactive power, and giving active power. That's why we are not using this induction generator. So we are using induction machine as induction motor nowadays very in extent 80 to 90% area we are using this. It is also called asynchronous machine. Why it is also called asynchronous machine? Because it is rotating not at ns speed. When speed is less than ns, induction machine act as what? Induction motor. When speed is greater than ns, what is this speed? Speed of rotor, okay? Then the machine will act as induction generator. This is the construction part. This is a stator basically. In a stator, we have three-phase winding, which is distributed in nature. The winding of each phase are distributed over all several slots. It produces a revolving MMF, that is rotating magnetic field basically. This is a rotor. There are two type of rotor we have seen, squirrel cage rotor as well as slip ring rotor. In a squirrel cage, there is no winding, okay? There is just a copper bar. This is just a copper bar, nothing else. Aluminum or copper bar is inserted inside the rotor slots. This bar are shorted by rings at the both end. The rotor behaves like a short circuit winding. Simplest, okay. It is simple and robust slip ring motor. It has the same form of stator winding. So this is a rotor part, okay? This is a rotor. There is no winding in rotor. But in slip ring, here we are not having, I think this is slip ring rotor. We have a winding in this, okay? Here we have a winding in slip ring induction motor because later we will see that how we are controlling the speed by inserting the resistance, okay? So in this type of scenario, we are using slip ring induction motor. When we want to increase the torque, we are preferring the slip ring induction motor. In squirrel cage induction motor, how we are controlling the speed we will see later on. Okay, so now we will see the power flow in induction machine. So here you can see the induction machine. What is the real induction machine? So this is the real induction machine, and this is the power flow. Basically, by parts it is there, but I will show you the power flow in induction machine. Just wait, okay? So let's assume this is the stator. In this, you are supplying a three-phase power supply. Balance it, okay? It is balanced. Three-phase balanced power supply. We will see mathematical later on, but when you supply three-phase power supply to three-phase winding, you will generate a rotating magnetic field and it will generate a air gap power. In the induction motor, you have a rotor. After that, there is a shaft, right? This is a shaft. This is a air gap. So this is P input. This is P air gap. This is rotor input. This is rotor output. And this is shaft output. Okay. Now we are seeing just a power flow basically, nothing else. Okay. What is P input? The power we are supplying to three-phase winding, right? After that stator, there is a rotating magnetic field. There is a air gap power, and which is equal to what? Rotor input. So I can say that rotor input equal to air gap power. Okay. And there is some loss like stator loss. Oh, sorry, rotor copper loss and rotor iron loss. Same like here, we have a stator copper loss, stator iron loss. So P input minus stator copper loss, stator iron loss, we have a P air gap power, okay? And this P air gap power is equal to rotor input. And when you rotor input minus rotor copper loss, rotor iron loss, you will get what? Rotor output. So you can write what? Rotor input minus rotor copper loss minus rotor iron loss. So then you will get what? Rotor output. This is shaft basically. It will rotate. So it has somewhat rotational losses. So when P shaft, how will you find out P shaft? Rotor output minus rotational loss. You can find out the net power. So this is a power flow diagram of induction motor basically. Okay. In induction generator, the power flow is reverse. Nothing change, just reverse. We will see later that by numerical we will analyze the things that how power is flowing. We will definitely do the numerical and just analyze the things. Okay. So at the end, I would like to conclude that induction machine is simple construction. Basically, simple. It is very simple construction. It has robust and rugged structure. Third one is least maintenance and repair cost, good efficiency, no armature reaction, just like we have in DC machine and all, commutation issue, Last one is that controlling is easy. Control of induction machine is easy. In practical scenario, like in the railway traction, or that we are using induction motor, there we are using control techniques. So there are various type of control techniques we are using there, like vector control methods and VYF control method to control the speed and all. In open loop control, in power, in closed loop control. So in power converter side, basically in power electronics, we will see this kind of basic things, not full thing. Basic thing we will do it. Okay. So this is all about today. Thank you.